We already discussed particulate matter, carbon dioxide, carbon monoxide, and today we have two sessions about ozone and formaldehyde at 4 p.m. Central European time. So let me jump to ozone. Okay. So the session it's going to be short unless we have lots of things to discuss, and mainly are the same thing like what we have discussed on previous sessions from carbon dioxide, monoxide, and particulate matter. One of the things that we are discussing is the space adaptability feature, whether it makes sense to have it, or as some of the comments are suggesting, having a target limit and ceiling limit, like a maximum, in order to avoid confusion and make things easier as well for us and also for the companies that build instruments around their quality. Yesterday, for example, in the carbon monoxide meeting, which was quite relevant, we discussed like the possibility of having a ceiling limit extrapolated out of the average limit that the common standards have. And I would like to ask the participants of this working group if you have any additional comments regarding the space adaptability feature or any concerns. Hero, please.
I think that the adaptability should follow also decision of other pollutant as well. If the decision is not to have adaptability of the others, maybe also for ozone should follow the same.
Mm-hmm.
And the only thing that I would like to highlight, I don't know if it's been already done in the maybe in the comments, that we have to take care about two type of ozone pollution. One that is normally in the environment, so ground level ozone that can come inside from the outside, and the other ozone normally is produced by air purifiers and equipment that are introducing the ozone as genetic ozone in the with effort to clean the air. There are a lot of cases of ozone misuse or equipment that are promoting to be ozone free and they are not ozone free.
Mm-hmm.
So these are the two things that I think we have to take care. What is a natural ozone you cannot get rid. You can get rid, of course, by isolating the outdoor and the one that is produced indoor.
Yeah.
Indeed. Please, Chanli, if you have a comment.
Yes, absolutely. The regulation on air purifiers is how to say that is not that strict, and so the lot of technology will generate ozone. So in the test rig, um, they can meet the requirement, but you don't know uh, what the condition it was tested, because for air purifiers there are so many settings you don't know. That's and then for the test rig,
Mm-hmm.
uh, in the test rig, the test didn't made any requirement what condition the units are used, etc. Are tested. That is something really scary. So because as air purifiers, it is supposed to clean the air, not to create a problem. So in summary, even they can kill bacteria viruses very well, and doesn't mean this is good air purifiers as such. And especially ozone is a very very good method to kill bacteria viruses. So in that means, when they did the test for ozone, maybe is not that effective to kill bacteria. And when they test in different test rig to test the bacteria viruses removal, and they are using different setting, and ozone contribute to the impact, and we there's no regulation to say what's
Mhm.
going on there. Yeah. So,
You're
but
right. Yeah.
yeah,
There
but
are
the can,
many products out there that unfortunately produce ozone in the process of eliminating some of the pathogens, and this is
yeah,
one of the reasons basically we had ozone in even in this first version of the Go EQS, in order to keep in mind that some of the solutions around air purification or pathogen elimination are
yeah,
not so pure in heart, and they have those byproducts as as a result of killing those pathogens. And not only air purifiers or UV lamps, let's say, and other solutions, but also cleaning products can produce ozone. Like I have
yeah,
seen many places that they use peroxide as their agent to disinfect, and the chemistry changes constantly inside the indoor space because of the presence of peroxide, which is another oxidant and accelerates the formation of ozone in indoor space. And
yeah,
something else that Kira said, when outdoor air quality and ozone is present, in most cases, some scientific papers say that once this air comes inside through the ducting system, it's going to be not eliminated, but it's going to be converted in something else, which we do not know what will be. Kira, I see you have raised your hands again.
Yeah, you're right, totally right that the ozone is unstable and can be easily converted in nitrogen pollutants. And it's very, very complicated to understand which is the reaction, the chain of reaction that can be first, second, and third that can bring also much more harmful pollutant. Because
Hmm.
ozone, okay, is not harmful itself, is not because it's irritating, it's just oxidizing. But there are other pollutants that can be created by accelerating some reaction by the ozone. But regarding the regulations, for example, in the United States, there is UL regulation at two levels, and one of those is restricting the production of ozone from equipment, air purifiers, and so on, if I don't remember wrong, to 5 ppb. That is very, very, very low limits. If you are living, for example, in Southern Europe, like Italy or Spain, whenever you are trying to close everything, you just open a window a little bit, you will never get it to have less than 10, 15, 20 ppb of ozone inside the environment. So there are regulations, I
Hmm.
think sometimes too much harsh to be reached, like UL, and also depending on the geographic area. Like for example, south of Europe, where there is a lot of sun, it's not easy to get rid of ozone. Like for example, in Italy, in outdoor environment, we are measuring up to 100, 150 ppb of ozone at the ground level outside, and very, very not easy to avoid this bringing inside.
Yeah, and outdoor ozone also it's time dependent. Basically, during the peak hours of the
Yeah,
sunlight is higher than in the afternoon, and it
exactly.
converts between nitrogen dioxide as
Yeah.
well, VOCs and ozone all of the time. So yes. So going back to the question about the space adaptability, do you think that we have to adopt like some hour average for the different indoor spaces, or should we come with a limit? What's the opinion of the participants here?
For me, whatever is easier to give the right sign that we are taking care about
Hmm.
ozone without making things too much complicated. Because if we can adapt to geographic zones, like for example, South of Europe, Northern Europe, but makes too much complicated to understand. And even if we can adapt, for example, for gyms, because we assume that there is some use of ozone to clean, it makes the things complicated as well. So in the perfect world, we can also adapt, but
Hmm.
in the pragmatic approach of Go QS, I think the easiest things to communicate, to bring something that can be easier to understand, should win over the perfect approach. my opinion.
Thank you. All right. And as you already know, I have listed all of the limits and guidelines that they are available out there. Again, with ceiling limits, 15, 30 minutes, 1 hour, 8, 24 hours, average times, and 1 year. And the limits that they don't specify whether the numbers that they're proposing are based on ceiling or and time average, we have them under unidentified. And we try to adopt the strictest numbers, basically, from what we could find out there. And for this reason, for ozone, we went with 100 micrograms per cubic meter for the annual mean, which comes from India. Thailand has set 24-hour means with 100 micrograms again, recently, 2 years, 3 years ago. Lithuania has set ozone at 30 micrograms per cubic meter for 8 hours mean, and then China again at 100 micrograms per cubic meter for 1 hour mean. So again, looking at the numbers, and most of the people that they took the survey, they agreed. It makes sense to drop the space adaptability and have like an average or a ceiling limit, which would be the most strict that we can find. Because again, we are communicating the same numbers over and over again for different average limits. I don't know if you have a thought on that. As again, based on the standards that we analyzed, 100 is like a predominant number for ozone. And for 8 hours is 30, which is the lowest that we could find.
I was just converting because I'm used to ppb and not to micrograms.
Okay. That question comes later, which unit we should use. But I mean the conversion with all of those numbers, in most cases they are more or less the same thing, right? Like I don't
Yes,
know
yes.
the exact number now in ppb,
You
but
have to divide it by 2.
Okay.
So 100 micrograms should be roughly 50 ppb.
Mm-hmm. Again, with 25 at 25 degrees and 1 atmospheric pressure, right?
Yes, of course.
And also based on the literature that we could find, ozone is not, from all the literature that I read, I couldn't find that it affects human health the same way some other pollutants. So maybe more research is needed. But in many cases, they have to exaggerate the concentrations in order to see huge effects on human health. And I don't know if this is because purely they're measuring ozone or because it converts easily to something else. But it's well known oxidant, right? So it's going to irritate even the airway if you breathe it in high concentrations. In some cases, they say they irritate even the eyes because of the water that we have on the surface of the eye and may help in creating some oxidation in the eye surface.
Yeah, yeah, yes. You know already, we can convert ozone into oxygen
Mm-hmm.
in our biotechnology. Yeah, so that's why all our devices has very low ozone test result in rigs.
Okay.
Yeah.
Those are some of the comments that we read throughout the survey. Again, space availability, they were talking about manufacturing facilities and warehouse. This comment is common in the other working groups as well. And we are not going to have occupational safety limits in GoQS. We are not targeting those areas. Then another comment, we can adapt the stated limit for now, although I do think the China standard is too high. Maybe this comment is yours, Kira? For 1 hour mean, it's about 51 parts per billion, which does not make sense to be higher at 8-hour standards. The US EPA ambient standard is 70 parts per billion for 8-hour exposure. So maybe provide the units in parts per billion instead of micrograms per cubic meter, since ozone is a gas. In your Google Sheet, the one that I've shared with all the standard, it will also be nice to have the references example. I'm not aware of indoor ozone standard, but it appears that you were able to find one for ozone. Yes, I was able to find some indoor standards for ozone, although it is true they're not common. And then another common comment, sorry, is from another person. UL sets very concentrative levels of indoor emissions from indoor equipment, air purifiers, much lower than 100 or 30 micrograms per cubic meter. Also should be considering that some geographic areas has a high level of ozone, outdoor ozone at ground level that can easily go inside window and opens. All of those factors are taken into consideration. Yes. Anyone has any comment about those comments? I think we discussed them already. And then another thing that we have to discuss is how we are going to measure ozone. I should have included here parts per billion as well, instead of parts per million. But yeah, WHO use those micrograms per cubic meter, like for every other pollutant out there. Should we go with micrograms per cubic meter or adapt the parts per million? As the comment also suggested that we are talking about gases, and the conversion also in some cases can be problematic because maybe we don't have information like temperature and the atmospheric pressure that represents the gas.
In the case of ozone, it's a ground level concentration ranges between 50, 100 micrograms per cubic meter. It's equivalent to ppb. Almost we have to double to have the ppb. So I think the ppm or micrograms per meter cubes is too much, not enough to express. We should have like a 0.1, 0.2.
Okay. Someone else disagrees with Kiri's opinion? Should we move with parts per billion for ozone measurements or not?
Yeah. This is hard because it's basically it's based on people's habit. Yeah, so maybe we should follow the units what WHO use, and so that is more widely adopted. Yeah, I'm not sure if it's the right opinion, but if WHO promoting it, and maybe it's a lot easier for us to for people to follow this guideline standard as well. Yeah.
We always have the option to include both numbers
Yeah.
inside the standard, but again, it comes to how people measure different pollutants, right? And in most cases, they will use those parts per billion. Like a few weeks ago, I was inside a reference mobile station that we have here in my city, and they had like high quality instruments, reference instruments, and they were measuring ozone, and I was paying specifically attention to the ozone machine as it was measuring the concentration in parts per billion, right? So eventually what's happening is that the scientists are taking those parts per billion and then they have to convert them. I'm not always sure if they take into consideration those factors, like are they going to convert the units based on the temperature that they were taken or based on a standard temperature of 25 degrees 1 atmosphere? That's always the question. And to be honest, I have no idea what they do at the end of the day. Also, like if we are talking about small deviations, like I don't know, my plus or minus two, it doesn't make lots of difference at the end of the day. Uh, but as in many cases, we are talking about how we can correlate all of those numbers that we have measured with health effects. And the scientific community, epidemiologists also, they use those numbers in order to determine what's the, for example, they say every increase in 1 microgram per cubic meter, it has a decrease in, I don't know, or an increase in chances of cancer, let's say an example. So then the absolute number is necessary in those cases, but in everyday measurements for buildings, it's not so relevant, the absolute number, according to my opinion, always.
Yeah, I agree.
Yeah.
Might give you a little tiny experience that we have done to correlate the outdoor monitors with the stations. Like for example, in Canada, the official station are expressing all gases in ppb or in ppm, not in weight per volume. And their official station is standard as well. And it's quite uncommon because normally in Europe we see most of the official information provided in microgram per cubic meter. But I see that there is something probably changing to move to ppb.
So I think it's maybe we can write something like a guideline inside the standard where we
Yeah.
mention that it is recommending using parts per billion, but if you use the micrograms per cubic meter, then consider the factors of conversion based on the time of the measurement and the conditions that you took the measurements, right? If you are looking for this absolute number and accuracy.
Yeah.
Also,
Yeah,
for course, the modeling world also relies on PBB.
Okay, good to know. All right, and that's all basically for this session. I don't know if you have any more questions. I think we have to consider again creating a ceiling limit for ozone as well, rather than have those average limits, just because based on, again, the literature, the numbers that we can see, in most cases, they are around 100 micrograms per cubic meter or 50 ppb, let's say.
Yeah, absolutely. Oh, also, maybe it's good idea. We can have a kind of sense measurement. What that means is ozone is something people can detect with their eye or how they feel. And for a normal young women and what they feel at what kind of concentration, there's a literacy, there's so many of them. So maybe this is a kind of give it a kind of a sense and at what level people intend to feel in their eye is not comfortable or something. So could basically to taught people what is happening in the indoor environment. And especially nowadays, we're using so many electronics. You never know which unit, which electronics is contributing a lot of other ozone from it. Yeah,
I've
to the environment. And
Yeah.
if you don't feel right, there's something wrong. Yeah.
I've read in one paper that even ceiling fans, a simple fan, can produce ozone, actually.
What?
So
What?
even a ceiling
Motors.
fan, yes, a motor can
Oh, yeah,
produce
yeah.
ozone.
Whenever there is a sparkle, it's producing ozone.
Yes, Absolutely. When there's a high voltage, a little bit high voltage, and that will create the ozone
Yeah.
by using a high voltage something. Yeah. Yeah, that I totally understand. Yes. Yeah. Yeah. And photocopier and a printer and your screen and some of the screen, but not all the screen
Hmm.
and all the other units of electronics you are using at your home that will generate it. Yeah.
Yeah, and old CRT TVs with those big, huge tubes that they had, they used to run around 10,000 volts.
Yes.
So those they do produce ozone. Yes.
Yes. Yeah, absolutely. And then so because NOx, SOx, and ozone and formaldehyde,
Hmm.
and that's the three thing we are very strong on removal and breakdown as well. So, so it's basically that's our. Sometimes we tell people, this is our focus. Yeah, yeah.
Thank you.
Okay,
Okay. So unless someone wants to say something more, I think that's all for
Just,
today.
just
Please.
okay.
one
So,
one
are
more
you going?
comment.
Yes, yes, please. Go ahead.
One more comment about the, because this is repeating the question about in every group, if we have to use ceiling or we have to adapt to averaging over time. Maybe simplifying with ceiling is the most faster way to communicate. And probably when you add the comments to how to use this one, you can also give some indications about how to uh, which are the best practice to average, not as the first to determine the index and so on,
Hmm.
but as a guideline. Like for example, the ceiling limit is 100, but if you want to have an effective environment that is safe, try to bring an average of 8 hours less than 30, for example.
Okay.
That can be uh, keeping both words, but make simple to produce the index.
Hmm. The main reason we created this space adaptability was the fact that we saw that, especially green building organizations, they struggle in communicating air quality and what's the air quality needs in different environments. And I say that because, like in a hospital or in a fitness center where occupants may require double the amount of air because they are working out and they are breathing faster. So in those cases, in many cases where an athlete during 1 hour of exercise is going to breathe the same amount of air like a sedentary person during 24 hours. And how are we be able to, protect that individual in this specific setting just because he's breathing so much more air than someone sitting in an office, if that makes sense.
Yep.
But again, unfortunately, the literature around standards does not agree with this logic. So the numbers that we were able to find, they don't agree. Like 1 hour is the same thing like 24 hours here. So that's the reason we are going back now and possibly suggesting a ceiling limit instead of those average hours.
And it's not only that, but athletes have like a different structure. The lungs, like the position in the lungs, is much higher because of the way bifurcations are. So
So, so what's the problem of that? Like, what's the consequence of them having the lungs higher?
the position, right? Like the position in the lungs, right? Like it's at much higher level. Not just the volume of air that you inhale, but the structures themselves are like, essentially more like surface area. I remember my advisor claimed that that is the reason that he did not exercise.
Okay. But also, when you exercise, you also breathe deeper. So you may potentially bring those pollutants into more regions inside the lungs,
Yes.
like if you're breathing slowly and peacefully. Okay. Once more, I would like to thank everyone for joining. The amount of information that I have to process is quite big, so I don't think I will publish the conclusions from all of those meetings this week, but next week. I've started today and I see that the volume is too high, so please be patient and always feel free to comment after the conclusion.